Okay, now for the last video and the last exercise, the last example in this section. We have a nice geometric figure here. We've got a circle, and we have a couple of inscribed triangles. And notice we have an angle 1, an angle 2, angle 3, angle 4, angle theta. O is just the center of the circle. Let's take a look at what is being asked. Given that AB is equal to AC, so that length there is that length there, that means that one notch. So we have an isosceles triangle inscribed into this circle. And CD is a diameter. Okay, CD is a diameter, which means it passes through the origin, and it breaks the two circles up into the one circle up into two half circles, or two semicircles. We need to find angles 1, 2, 3, and 4 in terms of angle theta. And angle theta is angle A, B, C. It's marked right here, theta. All right, well, we know that the measure of angle 1 is equal to the measure of angle 2. So they're the same because we were given that. So we have an isosceles triangle there. And what is that going to be? Well, the measure of angle... I'm sorry, I said that incorrectly. Measure of angle 1 is equal to measure of angle 2. This one and this one. By the inscribed congruent corollary. Those angles intercept the same arc CB. So those two are congruent to each other. And what is angle 2 equal to? Well, in terms of theta, if this is theta, then this angle is also theta here. So theta and theta is 2 theta, plus the measure of angle 2 has to add up to 180. So the measure of angle 2 is going to be 180 minus 2 theta. The theta is the measure of the two base angles of the isosceles triangle. So that third angle is going to be 180 minus 2 theta. So we're using the inscribed congruent corollary for angle 1 being equal to measure 2, the measure of angle 2. And then we also use some facts about isosceles triangles. All right, number 2. What is... Okay, we're done with 1 and 2. Now let's get DBC. What is the measure of angle DBC? And it's not theta. Theta is ABC. What is DBC? Well, because that triangle has as one of its sides, the hypotenuse, is the diameter of the circle, we know that every angle, every triangle embedded inscribed into a semicircle is a right triangle. This is that's a right angle. So that's 90 degrees. DBC is 90 degrees. Angle inscribed in a semicircle. Okay, now let's see what we can get for the measure of angle 3. Angle 3 is here. Well, angle 3 is part of that right angle, right? So that means that the measure of angle 3 plus the measure of angle 1 has to add up to 90 degrees, correct? 3 and 1 have to add up to 90 because this one is 90. And 90 gives us 180. So we could say that it's just 90 minus the measure of angle 1. But we're not done yet because I don't want it in terms of the measure of angle 1. I want it in terms of theta. But we know what the measure of angle 1 is. It's 180 minus 2 theta. So from above, we can say this is 90 minus, what's the measure of angle 1? In parentheses, you have to say 180 minus 2 theta. Okay? And what is that going to be? Measure of angle 3. I'll write it right here. 90 minus 180. That's negative 90. Let's see. Negative 90. And then that's going to become plus 2 theta. So 2 theta minus 90. That's the measure of angle 3. Right there. Now we need to get the measure of angle 4. Ooh, angle 4, that's an interesting one. Right here. Angle 4. Well, notice that the triangle, the angle 4 is in this triangle, and we know one of the angles is theta, and the other one is angle 3. So the measure of angle 4 is going to be 180 minus the measure of angle 3 minus theta. So I want it in terms of theta, so I need to get rid of this measure of angle 3, but I know the measure of angle 3 is this, 2 theta minus 90. So that would be 180 minus, now I have to put that whole thing in parentheses, 2 theta minus 90, and then minus another theta. All right, so what are we going to get there? Excuse me. Well, the number part of it will be 180 minus negative 90. 180 plus 90, that's 270. And then minus how many thetas? Minus 2 theta and minus 1 more theta. Minus 3 theta. Okay, so we've done the first part. We have written the measure of angles 1, 2, 3, and 4 in terms of theta. That was 90. Okay, so now let's take a look at the last part. It says if the triangle OBC is equilateral, find out what theta is. Okay, so let's see what that means. Triangle OBC, this one right here, that uses the center of the circle. OBC. Well, what would that mean? What would the measure of angle 3 be if it's an equilateral triangle and one of the angles is angle 3? Well, all three of them would be 60 degrees. So that means that the measure of angle 3 would be 60 degrees. 3 congruent angles, because what if OBC is equilateral? Now we're going to substitute from above to find out what theta is. The measure of angle 3 is 60. But we know from above that the measure of angle 3, I'll write it down again, is equal to 2 theta minus 90. So all we need to do is set 60 equal to 2 theta minus 90 and solve for theta. So 60 equals 2 theta minus 90. That would mean I'm going to put 2 theta on this side. 2 theta. I need to add 90 to both sides, and I'd get 90 and 60. That'd be 150. And then divide both sides by 2, and we get theta equals half of 150, which is 75. That completes the problem, and it completes the section.